Just 3 weeks after Rita scared the living daylights out of Texas and Louisiana, the third Category 5 hurricane of 2005 starts taking its first wobbly baby steps in the Western Caribbean. Wilma grew up fast and mean, becoming the strongest hurricane on record before spending a raucous weekend in Cancun. Not done, Wilma turns east, riding the jet stream towards southwest Florida. That's where hurricane hunter Mark Sudduth is waiting.
I've just barely had time to get recovered from Rita. Replaced all the storm cases lost in Katrina.
While most people try to hide from hurricanes, Sudduth seeks them out. His mission, to document the monster storms as they collide with the coast and put those images on the internet for all to see.
The camera is just a tiny, tiny little camera. And the lens face is so small that hopefully the rain won't affect it too much.
When Wilma rolls ashore just before dawn on October 24th, Sudduth is ready with remote cameras in 3 southwest Florida towns: Naples, Everglades City, and Marco Island.
You'll see any surge come from that way once the daylight comes.
Unbelievable.
This view from one of Sudduth's remote cameras on Marco Island captures the advance of the storm. This time-lapse shot literally shows the storm surge coming ashore, flooding the street and swallowing that fence.
And we recorded our highest wind gust on our anemometer on our vehicle on the backside, very close to 135 miles per hour in a gust, a real quick stab right down out of the atmosphere.
This is what a 135-mile-an-hour gust can do. And this, and this, and this. As hard as it is to rebuild, residents of the Gulf Coast know that enduring such danger goes with the territory. But 2 back-to-back record-breaking seasons, some are beginning to wonder what is going on. 2 recently published scientific studies suggest that our current spate of violent hurricanes is the result of global warming.
The papers, Nature and Science, are certainly very credible papers. They're written by world-class experts in hurricane science and meteorology. I think we need to look a little more carefully. It is tantalizing evidence, however.
Though many scientists believe global warming is heating the oceans, some remain skeptical, insisting that both climate change and the recent surge in violent storms is entirely natural.
This is not due to human-induced global warming. Although the globe has warmed the last 2 or 3 decades, there's no question about this. We consider this natural changes that would have occurred whether humans had been on the globe or not.
Since 1995, ocean temperatures have risen slightly, not just in the Atlantic, but in other hurricane-prone waters, such as the Pacific and Indian Oceans. If global warming is in any way to blame for the increase in hurricanes, then the Atlantic shouldn't be the only hotbed of activity.
However, those other basins since 1995 have actually seen a decrease in tropical cyclone activity and a decrease in major hurricane activity. So even though we've seen a major increase in the Atlantic, these other basins have not responded.
Hurricane researchers say storm frequency is determined by the Earth's natural rhythms. For centuries, they say, active seasons have alternated with calmer ones, depending on changes in ocean currents, temperature, and salinity.
We have to adapt to the fact that we're going to see more landfalling major storms in the coming years.
Scientists like Bill Gray see the forces of nature operating as they should, but there have been some bizarre firsts. In March 2004, an extremely rare hurricane formed in the South Atlantic, eventually striking Brazil.
This is a location that almost never sees development of hurricanes or tropical cyclones. Now this year, we had Hurricane Vince, a Category 1 storm, made its way over to Europe, across the North Atlantic.
Never in recorded history has a hurricane ventured that far north. On October 11th, Spain was the first European country to see one come ashore. There were no casualties or damage reported.
2005 is going to go down in the record books as one of the more active years we've ever seen. Not just in terms of the total number of storms and hurricanes that we've seen, but the intensity of the storms and hurricanes.
Intensity, the most dangerous characteristic of a hurricane, yet it's the least understood.
Why do storms intensify the way they do? Why do they intensify so rapidly? Why do sometimes they weaken just as rapidly?
Despite advances in tracking the direction of these killer storms, scientists still don't have a grasp on exactly why some hurricanes get so powerful. To find out, a major effort has begun to get a closer look at how hurricanes form and to take critical measurements during the worst of a storm. It's called the Intensity Forecasting Experiment, a partnership that includes NOAA and NASA. They picked the perfect year to launch the project, 2005, the year with the most hurricanes on record.
The jet aircraft that NOAA uses to observe hurricanes doesn't go through the hurricane. It tends to go around the hurricane. We try to stay at least 100 miles away from the center of the storm. The main purpose of the jet is to better measure the steering winds that the hurricane is going to encounter.
Stand by to drop. 3, 2, 1, drop.
Scientists drop instrument packages called dropsondes right into the powerful storm. On the way down to the surface, a dropsonde can measure wind speed, temperature, humidity, and air pressure, feeding the information back to computers on board the jet.
We're hoping the next year or a few years we can utilize all this information that we're collecting and get that into computer model to better make assessments of the size and the intensity of the hurricane.
Information that will prove critical as the current cycle of hyperactivity continues into the next decade or more.
The past 2 years have indicated just how bad things can get and how bad they're likely to be if the past is indeed a predictor of the future.
But can lessons from the past change the future?
We know that you have a chance of mitigating the hurricane or stopping it completely.
Will this scientist actually be able to tame tomorrow's hurricane? For residents of Florida and the Gulf Coast, the 2005 hurricane season has been a nightmare.
That's top of our house. That's part of our house right there. That's the other side of the house.
But for hurricane researchers, this season is the opportunity of a lifetime.
This is every hurricane aficionado's dream come true in terms of studying storms, but obviously very bad for society at large.
Wilma kills 21 in the U.S. and causes much more damage than anyone predicted. The quickly moving storm doesn't lose strength when it hits land and ends up slamming Florida coast to coast with Category 3 strength winds of up to 130 miles an hour.
The speed of a storm is a blessing and a curse. It's a double-edged sword. It's less time that hurricane conditions impact any one location, but at the same time also means that that's less time for the storm to wind down.
Cities on the East Coast like Miami and Fort Lauderdale weren't expecting a strong hit. But Wilma's winds turn high-rises there into disaster zones.
As you go up in height, even just short distances, wind speed really increases very, very sharply. You got to be careful of some of these high-rise buildings. You actually might find yourself in half a category stronger storm.
With more than 6 million people without power, supplies of ice, water, and gas run out.
No gas.
This is unbelievable.
Residents and officials around the country are worn out from so many hurricanes in one year. But the 2005 hurricane season is relentless. Before anyone can catch a breath, Hurricane Beta grows into a strong Category 2 hurricane with a bullseye on Nicaragua. The country evacuates thousands and mobilizes its army before Beta hits with 105-mile-an-hour winds and 15 inches of rain. Even before this year's deadly season, hurricanes have been the costliest natural disasters to strike each year, causing more insured property losses than earthquakes, floods, and tornadoes combined. The raw power of a hurricane is almost beyond comprehension.
The energy over the lifetime of a hurricane is on the order of several thousand thermonuclear devices. It's just simply astronomical.
In 1989, Hurricane Hugo caused more than $7 billion in damage throughout South Carolina. In 1992, Hurricane Andrew became a $30 billion disaster in Florida. At the time, the damage from Andrew was unprecedented. But since then, hurricanes have only increased, grown stronger, and cause more destruction.
Every year has been way above average.
In 2004, 4 major hurricanes hit Florida, causing nearly $50 billion in damage. It was the most expensive hurricane season ever, until this year. Hurricanes Dennis, Emily, Katrina, Ophelia, Rita, and Wilma have made 2005 the costliest on record. Total damages from all the storms, nearly $400 billion.
The past 2 years have indicated just how bad things can get and how bad they're likely to be if the past is indeed predictor of the future.
Residents know that hurricanes are one of the risks of living on the coast.
The price for living in paradise.
And it's a price many are willing to pay. 1/3 of the U.S. population lives on or near the Atlantic and Gulf coasts. Another estimated 3,600 move there every day. But now the price of paradise is getting higher.
I hate to be doomsday or prophetic about this, but really, we're in trouble right now.
According to climatologists, we are knee-deep in an active hurricane cycle that will last another 10 to 20 years.
The best advice I can give is that we all have to buckle down and really expect the worst is going to happen. There's no way to sweeten it or pad it. You know, we have built up so many people, so much property value along the coastlines. We're sitting ducks right now.
With so much at stake, can anything be done? At least one scientist has hope.
Theoretically, it is possible to control the processes which drive a hurricane.
Wade McGillis is an earth scientist and engineer at Columbia University. He says hurricanes have an Achilles heel, evaporation, a hurricane's fuel source. McGillis says if he can stop this evaporation process, he can essentially choke off the fuel and weaken the hurricane.
The processes for evaporation are very susceptible to surfactants or surface films.
He believes that a thin coat of oil may be all that's needed to disrupt the evaporation process and weaken a hurricane.
An oil spill is a surface film, but there are other both natural and synthetic surface films that can target directly at the heart of the energy and heat transfer from the ocean to the atmosphere.
McGillis says that a thin film of oil prevents evaporation when the water is still and calm. But he doesn't know if it will work at high wind speeds when a hurricane's fury rips the ocean with mountainous waves.
Just increasing in wind, you can see there's much more agitation at the surface.
To test his theory, McGillis built this tank, a hurricane in a box.
Literally, on a small scale, this is what the sea surface feels during a hurricane. Now when you have a very energetic system, where you really can't discern where the water stops and the air begins.
If his theory pans out, McGillis believes he could weaken a hurricane enough to prevent damage and loss of life.
If you were to reduce evaporation by 1/2, truly reduce the evaporative process by 1/2, you would probably stop the hurricane.
McGillis is testing biodegradable oils that he says would not harm the environment. And he doesn't need to use very much oil at all.
One thing that we have going for in terms of surfactants is that very little quantity goes a long way. And it goes a long way by itself. It doesn't have to be delivered. Just a teaspoon can cover probably 1/2 of a square mile.
But McGillis's experiments are just that. And it could be years before he knows if his idea is viable. In the meantime, the best hope of protecting the millions of people at risk is to predict where the storms will strike and get people out of harm's way.
We have some very heavily populated coastlines, and it takes people a lot of time to prepare or evacuate if need be. So what we're trying to do is provide tools for folks, better predictions, to get them ready in advance of the storm's arrival.
So far, hurricane prediction is an inexact science. But perhaps the efforts of airborne researchers and storm chasers and the use of powerful computers by scientists will someday solve the puzzle of why hurricanes can intensify so rapidly, where exactly they will strike, and whether it's possible to weaken them. As the deadly 2005 hurricane season has shown, figuring out that puzzle is more critical than ever.